Hi everybody. Today we're going to be looking at doing better ETL with managed Airflow in ADF. So please leave some feedback, not just for me, but for all the speakers if you get it, because it's what we use to try and help make these sessions better for you guys. So the more feedback you leave, the better they get, and the more relevant content we can give you. So my name is Niall Langley. I'm a data engineer, a kind of platform technical architect, building lots of data engineering solutions. I work as an independent consultant. I currently do a lot of work with advancing analytics. They're really nice guys. Hit them up if that's what you're interested in. I do a bit of blogging. I've recently redone that, so I'll be doing a bit more. And feel free to ping me on LinkedIn or have a look at my GitHub. The demos that we have for today aren't on GitHub yet, but they will be on GitHub, and you'll understand why when we get to that later. So, okay, today we're going to go through what is Airflow and how does that fit into the Azure Data Factory kind of ecosystem and tool. Why is it useful? How does it work? And what does it look like? Because one of the key things from this is it gives us much better reporting, monitoring of what's going on with our ETL, and that's kind of an important part of it, as well as actually doing it as code. And we'll go through a bit of a roundup at the end as to how this is applicable for what you guys might be doing and whether you should use it. So Apache Airflow, essentially, this is the quote from Airflow themselves. Airflow is a platform created by the community to programmatically author, schedule, and monitor workflows. So a workflow is something that is essentially a group of pipelines. So your pipeline will move data from one place to another, maybe do some transformations with it. This is there to orchestrate those pipelines, which is kind of what we do in ADF, but it works in a slightly different way. It's a community-based tool. It's open source. So there are lots of different kind of ways that you can run this. You can run it up in the cloud. There's various versions of it that essentially have support around them. But you can also run it on your local machine, and you can run it for free that way to learn it. Out of interest, how many people here use ADF? How many people use Airflow or some other kind of code-based tool? Right, cool. So this talk will be a bit more of a kind of like entry level to what Airflow is doing and how that kind of relates into ADF. So okay, what and why? So Airflow is a code-first workflow tool. That means that unlike ADF, where we're looking at building things in a GUI and we have JSON that comes out the other end of it, and it can be quite hard to understand from a kind of like look at the JSON perspective, this is all going to be code. It's all going to be Python. And we build them using DAGs. So we'll kind of drill into DAGs a little bit shortly. But essentially, we're looking at how we can say this thing runs after this thing and runs after this thing and define that with our code. It's got a powerful scheduling engine. The scheduling engine, as we say in IT, everything always comes back and comes around in fashion. The scheduling engine is basically the same as what you get in Linux, which has been around for 30 or 40 years. When we say it's solid and it works properly, it does. We use integrations to connect out to other services. So because it's built in Python and it's extensible, it's really easy to go, well, actually, it doesn't quite connect to the thing I want, so you can build something custom, and you can integrate that in. It's designed to be scalable and extensible. So it's similar to if you're using Databricks and you're using Python there, you can essentially make this thing scale out and give you much more processing power, but you can also scale it back in, and you can adjust that in theory. It's got a really good monitoring UI. So I don't know here how many people have got fed up with the ADF monitoring UI. Is that a thing? Quite a few smiles there, smirks from people. In trying to find stuff in the ADF monitoring UI, when stuff is either going right or going wrong, can be quite painful. And the monitoring UI on this is really good. It's open source and cross-cloud. So predominantly, until a few years ago, I'd worked with a lot of clients who'd kind of be quite Azure-focused, but some of the bigger clients now are starting to go, well, actually, we've got some stuff in AWS, we've got some stuff in Azure. If you're using just ADF for doing that part of it, you're kind of locked into Azure, whereas this is more of a cross-platform tool, and it gives you a few more options in terms of that. As I said before, you can run it locally. There's Docker images for it, so if you want to put it on your machine and just run something, you can. And where we said that it uses integrations to reach out to other services, you can set that up so that while it's running and doing the scheduling on your local machine, it can still reach out to those other services like Databricks or even ADF to do various things. And basically, it's the conductor for your ETL. It's going to be saying, this thing runs, and when that's finished, go and run that other thing, and that's basically what we're doing here. So, okay, so how does that relate to ADF, and what's this managed part of it? Well, previously, if you wanted to run Airflow on Azure, you were going to have to go and set up like a Kubernetes cluster and set up all the various bits that you needed. And most data engineers that I speak to are generally, if they come from more of kind of like the traditional data warehousing side, they've been learning a lot of Python over the past few years, they've been learning Spark, they've been learning lots of different things, and they haven't had that much time to go and really dig into Docker, really dig into Kubernetes and understand how all the containers part works. Maybe if you come from more of a software engineering background, that's a little bit easier, but for quite a few people, there's quite a heavy overhead there. As we can see, there's quite a few pieces that would run on that diagram. You've got a scheduler, you've got workers, you've got a web server for UI, you've got a DAG database. And if you were to go and set all of those things up in Kubernetes, it's not just a case of setting them up. If you're going to run them in production, do you know they're secure? If you've got a web server in there, do you know it's been set up in a way that follows security best practices? For a data engineer, for me, that's not really what I want to be doing. I want to be concentrating on actually building pipelines that provide value for my customers if I can. So ADF Managed Airflow is a platform as a service piece, and basically the idea is that you can just switch it on, turn it on, and ADF will manage all of that part for you. And the other thing that's supposed to be, well, should work nicely with this is it supports Azure AAD authentication. So if you spin up a Kubernetes cluster and you want to log into the web server for actually managing Airflow, then normally you'd be doing it with a username and password, whereas with this, you can actually just have that single sign-on that you're used to, and it just makes it a little bit nicer to use. So how is it different to Azure Data Factory? For me, when we talk about ADF, I always think of it as being kind of like this split personality thing, right? You've got a part of ADF, which is the copy activities and all the various sources that you can go out and reach out to collect data. And that's a really good integration tool on the Azure platform. But when it comes to orchestration, I deal with a lot of clients where we deal with quite dynamic, metadata-driven ETL. So we'll typically have metadata in, we want to read it in, we want to loop over to read all of the tables. And what happens at that point is you start to run into the limitations of ADF. You've got limitations in not being able to nest if statements. You've got limitations on only being able to loop over 50 items at a time. And you can't nest your loops, so therefore you have a pipeline that calls other pipelines, and it just gets very awkward and frustrating very quickly. So for me, ADF is not a very good integration tool. That, where it says Airflow, it should say ADF there. So essentially, ADF is really good if you're just trying to do simple little orchestrations and you're trying to just drag and drop things on and kind of proof of concept maybe. But it doesn't do those things very well. The error handling and the logging can be slightly awkward. If you want to handle errors in a certain way and then do something else, that can get quite tricky. And we don't have task grouping. So those of you who come from like SSIS, like I used to do way back in the day, you could put things in a box and then that handled, you know, whether or not you wanted to wait for all 4 of these things to run or just one of them or do certain things in that way. It doesn't have that ability. So it's not really very useful in that regard, and it's not extensible. If it doesn't do something that you want it to do, well, you either ask Microsoft really nicely and they stick it on a queue and it maybe gets fixed at some point, or you try and work around those limitations. So the idea that the industry is moving towards is this idea of ETL as code. So you can construct essentially what you do in the GUI, but you can do it as pieces of code, pieces of Python functions, and it becomes much easier to understand and read. So who here has taken a look at their ADF objects that get chucked into source control on some kind of big pipeline and gone, yeah, I've no idea what's actually linking together. Like if somebody gives you that and you haven't got ADF to hand and you're looking at the JSON, you go, yeah, I don't know what's going on. With this, the idea is that we can define our functions and then we can essentially define what the relationships are between those, and we get a much better end product in terms of readability. Things that I like about this as well is I do a lot of Python, I do a lot of Databricks. I like to use some of the tools like Flake 8 and Black, which allow me to essentially we enforce coding standards on the team. So we can check for things like just little things, but we can make sure that all the code is a consistent quality, and we end up with a better code base from that. People can pick things up and understand it faster. It also encourages modularization and reuse. So if you kind of do any software engineering, the idea that you can build small pieces and then plug them all together and actually reuse pieces is a really important one. For anybody who does a lot of Python and uses things like PyTest, you can actually test over these. So you can add tests that say, well, I would depend on this thing running before this thing over here runs. And if you get that right, you can build those in such a way that if somebody goes in and changes that code and actually breaks that, it will fail a test, and then you'll pick it up before it actually goes anywhere important. And because it's based on Python, you can extend it in any way you like. If Python supports it, you can do it. So when we talk about ADF and Airflow, basically, the idea that I have of how they fit together is that you would use Airflow for doing your orchestration and your scheduling. You can do things like running bash scripts, which you can't do with ADF normally. You can use ADF with very simple pipelines with just copy activities in there that are set up dynamically and parameterized. And then if you do need to copy data from somewhere, essentially you can just call out to ADF and just go, move that from there to there. And you can do it inside a loop, and you can fire off a whole bunch of them, wait for them to finish. And then you get the much better UI over the top of that. And because ADF is doing all of those copy activity pieces, if you've got strict networking rules and firewalls or on-prem data that you're trying to go off and grab, you get all the benefits of you've automatically got the integration runtimes that can be on-prem, and you can reach into all those sources and go through firewalls as you need to, the way that you would normally do with ADF. Right, so how does that work? So we talked about DAGs. Essentially, when we build Python, we're building DAGs. So this stands for Directed Acyclic Graph. And the idea here is that we have nodes. These are the things that we're actually going to do. And we have edges. This is how we're going to go from one to the next. And essentially, the key part of a directed acyclic graph is that we have a direction. We go from this thing to this thing. And we never go round in a loop. So if we've got a loop, it's not a DAG. And essentially, we can use this to represent a series of steps in processes. So you can see a whole bunch of different tools using DAGs. That one is actually ADF itself. This is just kind of a couple of loose examples. That one is one from Spark or Databricks. So lots of tools are using DAGs. So when we build our DAGs with Airflow, what are we building them from? We have tasks and we have relationships. So that's a node and our edge. And a task can be either synchronous or asynchronous. So when we talk about a task being synchronous, that means we kick off a task, it sits there, it does its thing, and it finishes. If I talk about an asynchronous task, it could be I want to go and post something and fire and forget, and I'm not bothered about it. Or it could be I'm going to go and talk to some web service to ask it to do something like deliver data, but it might take a while, so free up that resource so something else can run while we're doing it. So there's three different types of tasks. We've got operators, which are essentially just a simple task, go and do something. We have sensors, which work with the async tasks to basically say, I fired off something, now I want to use a sensor to find out when that thing has finished. And we also have this task flow decorator, which is used for Python functions. So we can take a normal Python function and turn it into a task, which gives us that extensibility. So tasks need to reference something in order to go and do some work. So a standard Python function will run as a standard Python function, but if you want to use the inbuilt connections out to other things such as ADF, Databricks, maybe whatever, there's probably a connector in there for, say, Synapse Spark or something like that, SQL Server, you can go and do that. And you use these connections to set this up. So connection is basically a connection string wrapped up into an object so that we can connect to that resource. The relationships are basically defined in Python as well. So this is saying this task depends on this one. And we can set things like descriptions on that at the same time, so we understand what those dependencies mean. And we have tasks, and we can group these into task groups and sub-DAGs. So this is where it gets slightly tricky in terms of how we group stuff up. So we said with ADF, it was very difficult to put 50 copy activities in something and then just depend on that group of them. We can do that with Airflow, but there's two ways we can do it. You've got sub-DAGs, which is where we're trying to encourage code reuse by building a DAG and then embedding it inside another DAG. Or we can have task groups. And task groups initially were more of a kind of UI-based thing. So a task group just says, take all of these tasks that I have, put them in this box, and now I can depend on all the things in that box for the next thing. But it doesn't actually break it out into a separate component that we can reuse. So you use them in slightly different ways, and there's a subtle difference between them. So, OK, Airflow DAGs sound good. In fact, they're awesome. How do we actually define these? So we define them with Python. So the first thing that we do is bring in the libraries that we need, the Airflow ones. In this simple example, we've got a bash operator. It's literally just on the executor, going to go and run a little bit of a bash script, Linux script. And we're basically telling it that we're going to be using the Python operator. So we define a task here, task A, and essentially we've defined it with a task ID, and we've told it what it's going to go and do. And then we've got another one, task B, and we've given it a task ID of task B, and it's just a bash command to go and do an echo. And at the bottom, we've got two different options for how we can define the relationship between those. So essentially, we've said that in order to run task B, task A must have run first. Run task A, then run task B. And we do that with this operator with double chevron. We can also specify the chevron the opposite way around, and it means the same thing if we swap the names around. So it doesn't necessarily have to always be task A is being told it depends on task B in terms of how you write it. And you can put multiples of these together, so you can just string them along and essentially make lots of dependencies show up within one. So it can be quite nice because you can put all of your functions or tasks together, and then you can have a section that just lists out essentially what your dependencies are. And if you have the names set up nicely, it's very easy to understand the structure of actually what your ETL is going to be doing. So when these things get built, you can set these up to produce a data set. And when you say that this task produces a named data set, you can actually use it so that when that data set has something happen to it, it can actually trigger another DAG to kick off. So you get kind of quite fancy triggering in between them. When we talk about a workflow, which is composed of these tasks, we will kick it off, and we can basically say, we're going to kick this thing off, and it will execute our tasks in parallel. So we have executors, which we'll get onto kind of in a second when we show the architecture. So we have a number of executors. Each executor has a number of slots on it. Essentially, we can run as many tasks as we can fill our slots with. And when our slots are full, that's the point at which we can't run any tasks, and we have to wait for something to finish to put something on again. Where we talked about having an async task, that thing will go on, it will start, it will kick something off and do its thing, and then it essentially goes, well, I'm just going to be sat here waiting, so I'll free up my slot, and that's when the sensor comes in, and essentially we use what's called a triggerer with the sensor, and that sensor, when it gets to the point of triggering, actually triggers the original task and puts it back in the slot in order for it to finish off its work. And this is what we call deferred tasks, so that's how that works. So Airflow kind of core concepts, how does this actually get structured? So a scheduler, which is what we use to actually set when something's going to run, is used to trigger the workflow, and that's used to submit the work, which is the individual tasks, to the executors. We can have one or more executors, and that's basically allowing us to do this scale out massively wide. So depending on how much work you've got, you can just kind of push this out. A trigger which executes async is used to execute the async tasks, as we said. But then once we've got kind of past that scheduling and things, we then, in terms of other components in there, we have a web server for the UI. We have a folder full of all of our DAG files. So these are just going to be Python files within that. There's a metadata DB that's in there that's used to track the state, which is used for the UI in order to tell us what's going on. And then we have a bunch of connections out to other services. So if you're using ADF, think of that as like your linked services, essentially. OK, that sounds good. What does it actually cost to run this thing? Well, it's in preview at the moment, so kind of costs are pretty approximate. It could change around as things go, and they do change this thing quite a lot. It's been a little bit tricky getting some of the demos going in the past few days. But essentially, at the moment, you can choose either a small or a large cluster, which is essentially determining how many nodes and executors you start with initially. You have the option to scale that, so there's a slider on it to add more. You have the option to auto-scale it, so you can have it auto kind of size a little bit. The one thing you can't do with it is pause it or turn it off. So it's not like some cloud services where you can just hit pause or turn it off and you're not getting charged. Once it's on, it stays on. Essentially, how does that compare to ADF? Well, ADF is charged for CPU time and the number of tasks run. So there are certain numbers of tasks that you get per month where you get that kind of built into having an ADF. So if you're just playing with it in dev, it looks really cheap. I've worked with plenty of customers where we've got quite a lot of metadata-driven ETL, and by the time we put in all the things to loop over stuff and actually fire off the things at the right time, the client comes back to us and goes, hang on, we've got a bill for ADF that's the same as Databricks, and Databricks is doing all the work. Why is the ADF bill so high? So the costs with ADF can add up quite quickly. In terms of doing dynamic metadata-driven ETL, who here plays with stuff where you're driving things dynamically with your metadata? Quite a few of you, brilliant. So when we talk about that, it's difficult to do with ADF well. In terms of how we do it, typically, if you're using your medallion architecture, you're bringing things into landing, and then typically we're going to automate that bronze to silver, raw to enriched, whatever you want to call it, layers, and we're going to try and automate as much of that, land the data in, and get it clean as we possibly can. And then from that point on, as we go into the gold layer, that's where we'll tend to maybe structure things a little bit more manually because we want to build out facts and dimensions and things. When we do that with, we're not going to actually do any of this in demo, but when we do that with Airflow, essentially there's two options here. So dynamic DAG generation is basically you run the Python, it creates you a DAG, and that DAG will be essentially dynamic at the point at which it's run. Dynamic task mapping is slightly different. So say you had a particular job where you're hitting a certain table, and you might go, well, this table is absolutely massive, and we need to pull it through, and we need to shard it a little bit. That might be where you'd look at the number of files that are there, and then use dynamic task mapping to actually spin out multiple tasks that are all going to handle one file each, and it would give you higher throughput. And you can use that to actually change the number of tasks at runtime. So one of them is at execution of the Python time when the JAG is generated. The other one is actually at runtime spinning me out extra tasks. And they kind of all get grouped together. And as they all finish, that's when the dependency kicks in and the next thing can kick off. And as we touched on, DAGs can define data sets. And those data sets can be used to trigger other workflows. So for example, you could have all of your things set for going into your bronze layer there, and you could define a data set on each one, and as soon as they go in, it could trigger another workflow that kicks off the actual thing that does the processing into the silver. So you can kind of break these things up and make them slightly more testable. Right, so we're going to go on to some demos now and actually have a look around what Airflow looks like in practice. So we're in Data Factory. We want to set this up. Where do we go? Come on to Manage, and at the bottom, we can see that we've got Apache Airflow down here. So in terms of setting these up, I've set one up already, because when you set one of these up for the first time, they take about 20 to 25 minutes to start. I've been playing with them with GitHub. I've been told that if you're using Service Principal for firing them up on Azure DevOps as your backend, it can take up to 2 hours sometimes to start them. If you get the Git configuration wrong, they can be a little bit painful because you can be sat there waiting for it to start for 25 minutes. And if you've got the configuration wrong and in the background it gives like an unauthorized error, it will sit here and it will say starting. And in that situation, you can end up being basically in a situation where it's actually failed to start and hasn't started properly, but it will just sit there saying starting forever. If we get time at the end, I'll show you where to look for that, essentially, to work out what's going on. In terms of setting these up, if we were to go and create a new one, we can go through, we can give it a name. we can set the authentication type. So the AAD authentication there, the Entra one, can be used to basically say, when I sign into the GUI, it's just going to automatically sign me in with single sign-on. Is it big enough for everybody? I can zoom in a little bit if it would help. That a little bit better? Okay. So we've got essentially that, or we've got the basic option. The interesting thing here is if we use the basic option and we have an Airflow username and password, we can only set one up here. I'm not sure how easy it is to set it up so you have multiple users within the kind of managed version. I haven't played with that. But if you use the AAD authentication, you can't use the Airflow CLI to actually connect to this and manage it from it. If you use the username and password option, you can connect from the CLI. But like I say, it gives you slightly different benefits or cons on each one. You can set the compute size here. So you can see we've got a small and a large option. If you're playing with it, be careful because the larger option defaults there, and I've just generally been using the small one. You've got a tick box that you can auto-scale, so you can set the minimum or the maximum number of nodes. And if you want to add extra nodes on this to scale it out, you can. You've got a drop-down for the Airflow version. There's only actually one there. It's not the most current Airflow version, so just be aware of that if you're looking through the documentation. The Git sync is kind of where we get this set up. So there's two options for pushing your DAGs into the Airflow component. Essentially, one is to tie it to Git, so that can either be GitHub or, let's see what they've got in here now, GitHub, Azure DevOps, we've got GitLab and Bitbucket. We can then set the credential type. So I've been accessing a private repo, so I've got it set up using PAT tokens. And then once you get into there, there's some extra bits at the bottom here. So you've got Airflow configuration overrides. Now, if you want to link this to Key Vault, this is where you need to set the correct configuration overrides to provide Key Vault as being the back end for storing all the connection strings. Once you've done that, you then need to set environment variables that give it the service principal name. However, there is a problem with that in this public preview, in that here's one I'd set up a few weeks ago, and you can see in here, when you go and configure that, sorry if it's a bit dark, the environment variables get stored in plain text, and there's no way of injecting in the service principal secret, which is really annoying. So if you're going to start playing with this, I would say it's probably best not to use the Key Vault one if you're going to think about how to use it in production, and then maybe think about using the CLI to actually go and configure your connections if you're going to be using CI/CD with that. But it's something to be aware of. And then you've got requirements in here. This is basically just allowing us to do basically pip installs of various Python libraries. So if you want to use different Python libraries within there, you add them in at the bottom. So this is the one I've set up earlier. If we have a quick look through, you can see that it's set up to use GitHub, and I've added in the ones for authenticating to Azure and the Databricks provider. So from there, if we click this little monitoring button, it will take us into the UI for Airflow. So this is what Airflow looks like. In this case, I've got 4 DAGs that I've set up and brought in via GitHub. And we get a fairly nice monitoring UI that sits over the top of it. So it gives us a quite simple kind of traffic light statusy type of view on top of this. So we can see that the green ones here give us an indication of how many runs we've had successfully or not successfully. We can see that we've got ones that have failed highlighted. The recent tasks over here is actually the tasks within the workflow. So we can see very quickly when we've got tasks inside of our workflow that have failed and understand whether, even though we might say that actually we're happy with that being completed as successful, were there any things that caused us problems within that. If we drill into one of these, we can actually see for the runs what the DAG actually looked like. And we can select here from the various runs that we've had. And essentially, this shows us the visual representation of what our code looks like. And along top, we've got lots of different icons along here that will allow us to actually view how these things look. So if we go into the calendar view, we can actually view when this is run, what the success or the fails were. So it gives us a nice overview, and you can see very quickly sort of when your ETL pipelines are running, where they failed, where they've been successful, whether you've had a problem over a certain period of time. This one here gives us task duration. So because it's only run a couple of times, it's not very useful. But it will basically give us a graph of how long our workflows are taking overall. So if you think that you've got times when your workflow runs and it's taking a little bit longer than other times, you can actually get a graph of that really quickly and easily. We can look at the number of task tries that we have. So if we've got tasks where they failed and they've got an automatic retry on them, then we can see how often we're getting those retries, how often we're getting failures within that. The landing times one basically gives us information about when stuff is actually running, when we're landing data into that, and we can see essentially when it came in and how long it took from that. You also have a Gantt chart, so this will actually break out all of the individual tasks within your flow. So if you think about ADF, where you kind of drill into one thing and then it kind of tells you what ran when, here you can really see exactly what ran, what things were running in parallel, what things weren't. This will give you the details of this DAG. So we can see at the top, we've got some failed runs, we've got some successful runs, we've got some upstream failed ones, which are kind of like warnings where it's failed, but then we've done a rerun on it, and then it's eventually failed again, which is why they're the same number. We can see a whole bunch of details within here. So we can see, essentially, is it started? When does it finish? You can set in advance, run this thing, but stop at this date. We don't want to run it anymore after that point. We can see how much concurrency we get. So we can say, actually, I've got this job, but it's not as important. So set the concurrency lower. And now, essentially, if it's running in at the same time as other workflows, we can essentially control what things are more important. So there's a whole bunch of information in there. And then we can get to the code tab, and we can actually have a look at the code for this one. So this is a fairly simple DAG. If we go back to the graph view, we can see, essentially, we've got the same thing running twice. So I've got begin, and I've got end. We always have those two things, because they essentially give us the anchor points for the beginning of our DAG and the end of our DAG. And then I've got two ways of running the same thing in ADF. So I'm running a pipeline, async, which is the top one. And essentially, it goes, run this pipeline, and then return. Because I know it'll take a little bit of time, and I don't want to be keeping that slot during the time where I'm just waiting for ADF to run, because essentially it would just be sat there polling it to say, are you finished? Are you finished? Are you finished? If you run it async, something else that's actually going to do some work on your worker can kick in and actually do some work, which is why there's then a sensor after it. The bottom one will literally just sit there and wait for the thing in ADF to finish. So if we were to run this, hit the run button, we can trigger it, and we'll see some information as it happens. So we can see that the async one went bright green really quickly. The next one kicked in and monitored it. And then the one at the bottom down here is still bright green, which tells us it's running. And at some point, the two ADF pipelines will finish. But we can see that this one at the bottom has basically said, I'm holding on to the slot I have, and I'm waiting for that thing to finish. Whereas the top one went, fire it, and then it's just polling in the background every now and then. And we can set that poll rate to say how quickly does it happen. So it's quite a simple DAG. If we look at the code for it, essentially we start our Python and we say with a DAG. So everything within this with block is going to be our DAG, and we give it some simple information. We give it a DAG ID. We've got a start time when we want to do it. We can schedule the intervals. So the intervals are all based on basically cron scheduling, but there's some kind of like nice keywords around that that you can use, like daily or monthly, or a certain time within the month. We can fire that off. We've got default arguments, and we can actually then replace those arguments when we go and run our DAG. So if you've got something where you might, in this case, want to fire it at different data factories, you can like pick and replace those in at runtime. So you could do that against your different environments. And then at the bottom, we've got as DAG. So we've given it a name. So we have our beginning and our end. So these are essentially empty operators. They just say, this is where I start, this is where I finish. They don't have to be empty operators. You can have an operator that's going to go and do something, like the first thing you might want to do is maybe make a log, and the last thing might be to actually say, log that we finished. And then we have our first task, so this one here. So essentially, this is saying we're going to run, we've called it run pipeline and wait, and essentially we've said this is what we want to do. We want to run it, we want to wait, and we have a check interval at the bottom. So essentially, if you set this too quick, then Airflow is going to sit there, and that thread that's polling is not going to be sleeping in between, which allows the kind of Python global interpreter lock underneath it to actually schedule work properly within Python. If you set that too quick, it's just going to be going and pinging all the time to go and say, ADF, you finished it, you finished it, you finished it. It's going to sound like one of my children when we sit in the car for a long drive. So you want to set that fairly sensibly. In this case, it's set to 3 seconds. That's for a demo. I wanted to make sure that you guys can see that it returns quickly. But have a think about how long your pipelines take and what you want the latency to be off the end of a job finishing. So we've got that one. That one sits there and waits. The next two work together, essentially. So we've got this one, which is going to run async. So go and fire off that ADF pipeline and just return straight away. And when it does, it basically is working as a deferred operator, and it works with this sensor underneath. So essentially, I'll scroll that a little bit more, and possibly even zoom it. So essentially what's going on here is we're saying that, okay, we've got a new task, but we're going to look at the async task that we've already defined to say, are you done? This poke interval is basically doing the same thing as we had before. It's telling it how often to actually go and poke ADF to say, have you finished? And we basically, the run ID is dependent on the output of the previous one. And then at the bottom, we essentially have how are the dependencies on this constructed. So we're saying that from the beginning, we are going to add a label to this edge, and we're going to say, don't do async and just wait. And then we're going to run our pipeline and wait. And then for the other leg on that, we're going to say begin, give it a label again, and then we're going to run async with sensor. And because we've defined already that our async one and our sensor are kind of bound together, so the sensor is checking the async one in order to fire it back off and say, have you finished? We can then simply say, for the two last pieces in the DAG, join them to the end. So that essentially gives us that structure that we looked at the beginning. And essentially, that's how we've built this DAG. So if we have a little look at a couple of the other ones, if it'll let me scroll, there we go. So yeah, and the other view that we had, sorry, that I missed out at the beginning, is the grid view. So this will show us all of the different runs. So in this case, the last 25 runs would be here. It will show us the duration on them. It will show us whether or not they failed or they've succeeded. And it will show us the individual tasks within those that workflow to allow us to actually see what things within it have failed and what things have succeeded. And then it will give us some stats on that. So that's a really useful view to actually be able to look at a number of runs and actually understand both timings and status at the end of it. So when we were doing that, before we jump into the other DAG, we were connecting out to ADF. So how do we set up those connections? If we're using Key Vault, then essentially we have to put in some Key Vault secrets and tell our tasks what the prefix is on them. And then essentially it will pull certain secrets in from Key Vault, and it will create the connections using the connection string stored. If we want to go and set them up manually, we need to go to the admin and the connections. So for anybody here who uses Airflow already, there are a bunch of the admin options that for this kind of managed version of Airflow have been turned off. So you won't see all of the options there that you would if you were running it separately. So within here, we can go in and we can have a little look. I've set these two at the top up. So I've got one that's connecting out to Azure Data Factory. And if we have a little look at it in there, I've essentially got what we would expect, a client ID for the service principal and a secret, and then telling it where the tenant is and the subscription, the resource group, and the factory name are actually optional. You can tell it those at the time that you create the task and use it. For Databricks, you have very similar. You basically tell it where the host is, and in this case, I'm connecting and I'm using a PAT token for myself. It is possible on Azure to generate out a PAT token for a service principal set up in Databricks, but it's slightly tricky. You have to do it with the Databricks CLI in order to be able to sign in correctly and generate the token correctly. So if we go back and have another look at a couple of DAGs, this particular one, task groups, looks like a really simple DAG. If we click on it, we can actually see that we've got multiple DAGs inside. So essentially what we've said is that the DAGs, the tasks A and B, and the ones either side of it are grouped into something, and that at the start we kick that off, and essentially the first one runs that's not labeled, then A and B will kick off, and once A and B are finished, the last one will kick off, and then we'll end. So you can group things up in order to simplify your dependencies somewhat. So if we were to go and have a look at the code for that one, how does that actually look? So again, we start with DAG, and we have a name for our DAG and what our schedule is going to be. There's a catch-up option there as well, so that's used for some of the slightly more advanced scheduling. You can go and have a read on how that works. And essentially, we've got the same kind of thing as before. So we've got our first initial node is start, so we're going to start from there. And we've used slightly different syntaxes this time. So we've got our with DAG, but then this time we've got another with, and we're using a task group. So all of the individual tasks that sit within this task group here are embedded inside that thing. So we've got a task group called A, and in there we've got a task, and we've actually got a couple of tasks within there. If we jump back to the thing in a minute, I'll show you how they're embedded. But we've got a couple of tasks, and then we've got a task group B, which live inside the first task group, and there's a couple of tasks in there again. And then we've defined an end, and essentially we've said, rather than using the syntax of a couple of chevrons to define our dependencies, we've said create a chain. I want to go from the start, I want to go to my task group called sources, and then I want to go to the end. And within our task groups, we've essentially defined the dependencies within there as well. So if we actually go back and have a look at the graph on that one, if we look at these, I believe these are task groups within there. So you can see that the task groups show up as blue, but the individual tasks show up in a different color. And essentially, we know that we are going to fire off task group A and task group B in parallel, but because they're inside nested task groups, we get these two little blue dots that just show us that we're starting from that point within that. They're almost like a start and an end point within that nested task group. So we've got a couple of others that we can have a look at. So we go back to the DAGs. We'll have a look at this one very quickly. So this is one where I've basically told it the name of a data factory that doesn't exist. So we can see that it's kicked off. And in this case, if we were to run it, we'd see that it actually runs and then it retries 3 times for each one. So you get that retry logic embedded in. And you can specify how far apart those would be. So if you're hitting something via an API, there's a chance that occasionally some network glitch happens and the API doesn't respond. Rather than having that fail, you can just say, try again in 30 seconds' time. But if you actually wanted to drill into this and understand what was going on, you can mouse over this and get a bit of more information. But if you click on it, you'll get a pop-up comes over the top. And if you go to the log, we can actually drill into this more. And essentially, you'll get an actual proper log. So anybody who's used to kind of reading Python logs from Spark or something like that, you'd be able to get into this and understand what's going on. And we can see in here that we've got a traceback from the exception that was thrown. And in this case, we can see that the connection ID isn't defined. But if we look at the line below, we can actually see that although the connection ID is not defined, there is a line in here somewhere that essentially says we can't connect to the specific data factory, and that's because I've given it the name of a data factory that doesn't exist. Wouldn't expect it to be there. So that's when you start getting things fail, this is the first place to come and look. That logging is not particularly easy to read in here, I don't find. My personal way of doing it is I will take that and I will basically throw it into something like VS Code, and then I'll start to actually search through it in a way that makes slightly more sense to me. You could push it into another tool such as Log Analytics, and you'd be able to then break it down and actually sort of shred it from that point using Kusto. The final one we'll very quickly touch on is number 4. So this one is a really, really simple one. This one just kicks off a Databricks task. So in this case, I'm kicking off a notebook. So if you were to have a look at the code for this one, code. In this case, we have a couple of extra imports to tell it that we're going to be using the Databricks ones. And in this case, we've got a dictionary defined to tell us what our notebook parameters are going to be. And then once we get into the DAG, we tell it what the DAG is going to be again. And then essentially, in this case, you can look through, but you can see, again, similar to the Data Factory one, this time we've got a Databricks connection ID, and it links to the ID of the connection in order for it to link back through. And we have an existing cluster ID. So obviously, the one I've put in here is hard-coded, but ideally, you'd want to make that parameterized, because then if you delete your cluster and start a new one, you get a new ID, and you want that to be a little bit more flexible. But obviously, it being Python, you can. Now, when you were to run a DAG like that, if you had parameterized it, if we were to go to this one, for example, hit the run button, you can see that you've got a trigger with config. And essentially, when you run this, if you've got configuration that you need to push in, you can push it in as JSON at this point, and you can set it up so that you can make things a little bit more dynamic. Okay, so that's pretty much it for the demos. So we sort back across the slides. Okay, so should you use Airflow? Should you use Airflow in kind of managed mode within ADF? The thing that I like about it is sort of one ring to rule them all, one language to rule them all. I like working in Python. I'm a data engineer. And for me, having one language that defines what my pipeline is doing and the same language to define how to link all my pipelines together and run them in the correct order is really nice. It makes it consistent. I can do much simpler automated testing with this. I can do linting for code consistency. If I want to make sure that I'm going to be firing the right things in the right way, because it's Python, we can start to think about how we mock external services to make sure that things are running in the right order and that we have the DAGs running correctly. We can build complex pipelines really easily. And because we've got things like reusability, we can take chunks and we can reuse them and we can do all of that kind of good stuff. The monitoring, as you can see, is far, far, far better than what you get built into Azure Data Factory. It's really easy to see when stuff is taking longer, when stuff is failing, and really get an understanding of, have I got jobs that are starting to take longer over periods of time, or am I getting performance regressions, or if I've made a performance improvement, how much of an improvement is it? It's multi-cloud native, so if you do need to be using both Azure and AWS or GCP, then you can use the same tooling across all of the clouds in a much simpler way. And if you're using Databricks with that, then you have a cross-platform Spark engine and you have a cross-platform scheduler. That makes it a lot simpler. The bottom one for me is a massive win. I really, really hate clicking around UIs, and I would much rather write code. But problems with it. As you can see, the nosediving plane. Big things for me, you can't pause it or turn it off. So we're used to basically services now that we've been using the cloud for a long time where we can just go, well, actually, my ETL is finished and I'm not going to be running anything for 6 hours, so let's just press pause and we'll stop getting billed. Can't do that with this. If you've got auto scaling on, it can scale it back down, but it's not actually going to stop billing you. Getting the connections to work with Key Vault is tricky. This is like understatement of the year. I spent 4 hours last night trying to get the demos to work with Key Vault. I spent another 4 hours this morning. And eventually I just went, you know what, I'm going to put the connection strings into the connections manually. So it's tricky, but also you get to that point where you look at it and you go, I need to put that client secret into the right place. And as soon as you do, and as soon as it deploys that integration runtime to create the Airflow instance, it goes and saves that straight into your Git repo. So that might be okay for your dev environment, maybe. I don't like secrets in Git at all, ever, because you can't get them out easily without doing destructive things. That isn't good if you've got things that are, sensitive, if you've got something that's covering quite a lot of environments. Deploying the integration runtime is awkward. It's either you fill it in by hand, or you kind of come up with a script, but that deploys it into the live side of Data Factory, and then you've got to go to your branch and actually import it back in. If you try and create it from the branch, it becomes a little bit fiddly. And there isn't CLI or PowerShell support. There's REST only. So the CLI support, like I said, you can do it if you set the authentication to be manual, but if you want to use Entra to make it nicer for your users, it doesn't work so well. Finally, it's in public preview, so if you're using it, they do say that there's a lot of changes coming in and out of it. My experience of playing around with it is that suddenly things will just break at the moment, so there is changes going into it. Hopefully, they'll fix some of these things fairly quickly. Here's a bunch of links for things that I read through as I was setting this talk up, so if there's anything that you want to kind of dig into more, have a look at some of those. And finally, if you could leave feedback, that would be really awesome. Again, it just really helps everybody make stuff better. It helps us make the conferences better. And yeah, all the speakers here would agree with that one. So yeah, thank you for being here.